For year 11 methods, we can look at exercise 11b, question 2 and question 5. Okay, so question 2, these are all without replacement questions, so it's hypergeometric distribution. So electrical component is packaged in boxes of 20. A technician randomly selects 3 from the box for testing. There are no faulty components. If there are no faulty components, the whole box is passed. If there is of any faulty components, the box is sent back for further inspection. If a box is known to contain 4 faulty components, what's the probability that will pass? So originally, you have a box of 20, so your big population is 20. You have 4 faulty and 16 normal in a box. Okay, so it makes up the box of 20. If I were to take a sample of, let's say it's a sample of 3, so it says 3 here. If I take a sample 3 out, what's the probability of that will pass? So pass means if I let X be the number of faulty in the sample, number faulty in sample, then the probability it will pass would mean X has to equal 0, because you have to have no faulty components in the sample, in the the sample you take out for it to pass. So all you need to do is you go to your calculator, you go this, you're going to go interactive, distribution, discrete, hypergeometric, PDF. So we want our X to be 0, we want no faulty components, our sample's 3, our defective in the original population is 4, and our overall population is 20. So I click OK, and I get 0.49122. So probability of X equals 0 equals 0.49122. So there's a 49.122 chance of getting no faulty components. Therefore, the box will pass. Question 5. A tennis instructor has 10 new balls, 10 used balls. If he selects 6 balls at random in the class, what is the probability there'll at least be 2 new balls? Okay, so again, it's very similar. You've got 10 new and 10 old. And the total population is 20. And from this, you'd select a sample of 6, so small n equals 6. And we're trying to find what's the probability if I let X be the number of new balls in sample. Then we want to find the probability that in the sample of 6 that we select, that it is at least 2. So X is greater or equal to 2. So all you have to do is you go binomial CDF, because you're going to have to add up a range of values. So I'm going to go distribution, discrete, hypergeometric CDF. Now, how many are we selecting? Up to 6. So we want at least 2 to 6. My small n is 6, because we're taking a sample of 6. Now, how many defective in the, or how many desired in our original population? Well, there were 10 new balls, so there's 10. And the whole population is 20. So click OK, and you get 0.9296. So that equals 0.9296. So it's really important that you understand what we're trying to solve for here, or what we're trying to find here. So it's really important that you type in the numbers correctly. So just recapping, the total population is 20. You have 10 new balls, 10 old balls. And we're letting the discrete random variable be the number of new balls. Right? So we're getting a sample of 6 from the original population, and we're trying to find the probability of getting 2 or more new balls. Okay, we're selecting 2 or more new balls. So that'd be 2, 3, 4, 5, 6. And what the binomial CDF does, it works out the range for you. Okay, the range of probabilities add for you. So